Hello, my name is Walter Unglaub, and this is Description of the Force that Keeps the Nucleus from Breaking Apart. A nucleus inside of an atom constitutes nearly all of its mass and is typically comprised of several protons and neutrons. The neutrons are negatively charged, so they don't repel or attract each other electromagnetically. However, since you just have nothing but positive charges from the protons, then you have an electromagnetic repulsion inside of the nucleus. And this is a very strong force compared to the gravitational force, so you might wonder what's keeping all these protons together inside of this nucleus? Well, the answer is the strong nuclear force. And the strong nuclear force is the strongest out of the four fundamental forces that we have observed in nature thus far. And it's described by the quantum description of QCD, or quantum chromodynamics. And in quantum chromodynamics, there is a different type of charge called color charge, which has nothing to do with the colors of the visible electromagnetic spectrum, but rather these different types of nuclear charges. And it's mediated by a boson, just like the electromagnetic force is mediated by the photon, which is a boson. In this case, that particular boson is called a gluon. And the gluon is also massless, like the photon, and it also has a spin equal to 1. So it has integer spin. And that's what makes it a boson. It obeys Bose-Einstein statistics. And in addition to that, we see that the gluon is responsible for keeping the protons and neutrons in bound states. So a proton, which has a positive charge, is comprised of three fundamental particles called quarks. It's comprised of two up quarks and one down quark. And the neutron, which is electrically neutral, is comprised of one up quark and two down quarks. The down quark is slightly heavier than the up quark, so the neutron is heavier than the proton. And because of that, the proton is actually slightly more stable. But this is the name of the force that keeps all of these protons and neutrons in a bound state, as opposed to it breaking up due to the electromagnetic repulsion. This is a stronger force than the electromagnetic force. My name is Walter Unglaub, and this is Description of the Force that Keeps the Nucleus from Breaking Apart.